Now we have a few questions. The first one is on distance time graphs. It says, which one shows an airplane moving at a constant speed throughout? And so you have 5 distance time graphs. You're looking for one which has a constant speed. So if you have a constant speed with a distance time graph, you know that you should have a constant gradient, because the gradient of a distance time graph gives you a speed, and if it is constant, it then should be a nice straight line. And so the only one that's like that is A. This one is just showing that the distance is staying the same. This one is showing you that distance is decreasing, and then it's staying the same. Distance staying the same. Distance increasing, meaning there's a constant velocity there, but then the distance is staying the same. Constant velocity there, but then distance staying the same. This is a question about speed time graphs. This is a very common question, and sometimes it's asked the other way around, that a ball is thrown up instead of dropped. Now when it falls vertically, it experiences acceleration due to gravity, and it is always constant. So if you have a speed time or velocity time graph, then you should have something with a constant gradient. Which one of the graphs show how the speed of the ball depends on the time it is falling? Now, if you drop it, you are dropping it from an initial velocity of 0. It's been dropped from rest, and it should be increasing in speed as it drops. So it should be accelerating. So its speed at the bottom should be greater. So you're looking for a graph whose velocity starts at 0, which is a large velocity at the end, or speed at the end, and which has got a constant gradient. So the only one that fits the bill there is obviously B. Sometimes you might be asked about a ball that's being thrown upwards, and then it's the other way round. It's starting with a greater initial velocity. It is decelerating on the way up, and therefore it's ending at rest. And so that would actually be this answer here, if this was a ball thrown up. Now, we find that confusing because we forget about the fact that the speed is decreasing as it goes up and the line goes down instead of going up. We kind of think of upwards must be an upward slope, but it's not in this case. So be very, very careful about that. This is another graph. It says, the graph below shows how the speed of a car changes during a short journey. At which time is the speed of the car greatest? So you have all these different times, and you can see there that the speed of the car is changing. And it's a speed time graph, so at which time is the speed of the car greatest? And it's obviously when it's got its greatest value there. And that's going to correspond then to time t. Now this is 1, 2, 3, 4. I know you can't see that, but it's this one here, t4. So if we were to describe how the speed was changing at any other point in this graph, we can see that it's changing constantly here, so that we would say that's accelerating. It's changing by lesser amounts here, so it's a non-constant deceleration. It's got a constant speed. It's decelerating here. Constant speed, then it's accelerating with a constant acceleration here, where it gets to this constant speed here, and then it's decelerating again with this constant deceleration. Luckily, in this question, we were only asked quite simply, when was the speed greatest? Below are 2 distance time graphs for the motion of 2 cars. This one should be a complete line there. There's just it's got a little bit over time, it's lost a wee bit of its blackness there, so I'll just put that in again. Car X and car Y. Which one of the following questions about the motion of the cars is true? X moves faster than Y. Y moves faster than X. Both cars travel at the same speed. Y has a larger rate of change of speed than X. And Y reaches a given distance from the starting point sooner than X. Now, if you have a wee look at the 2 cars, you can see immediately, straight line, distance time graph, it must have a constant speed. And so does Y. But obviously this has got a greater value of gradient here than this one, therefore it's got a greater constant speed. And so obviously car X is moving faster than car Y. Another graph, a train makes a stop at a station. So at that point its speed is 0. The passengers get off and the train moves on again. Which one of the speed time graphs below shows the motion of the train? So we need something with a velocity equal to 0 somewhere. So if you look at that, there's a velocity equal to 0 at the beginning and a velocity equal to 0 at the end. There's velocity equal to 0 at the beginning. There's one here where the velocity is equal to 0 along here. Now that one looks the best at the minute because we know that the passengers have to have enough time to get off the train. Obviously for the split second here and here that the car and here that the car is at 0, or the train is at 0, the passengers don't have time to get off. So the answer here must be E. Another question. A school bus makes its morning trip. Below is a distance time graph. Which one of the following statements is true? So we'll just go through them and see if they're true. So from K to L, the bus increases its speed. Now, this is a constant speed here, K to L, and we know that because it's a nice straight line on a distance time graph, and the gradient of a straight line gives you the velocity or speed, and that's constant. So that's not true. It doesn't increase its speed, it's got a constant speed. The bus has its lowest speed from M to N. Again, you can see there a nice constant line, constant velocity, but this is much steeper than that, so it's definitely not its lowest speed, so that's not true either. The bus has stopped from N to 0, or to O, N to O, and you can see from here to here the distance isn't increasing any further, so that's definitely true. The bus is its greatest speed, that should say from P to Q. P to Q is at rest, so that's not true. And the bus has reached the end of its journey at N is not true because it then continues to move a bit further. So the answer there is C.